So I only got 14 responses from these checking for understanding yesterday. So those people who tried, if you're placed next year in statistics, I assure you it's gonna be, I don't want to say easier, but at least you will have an idea of what we're talking about because you're at least trying, okay? And you have been already introduced to these concepts. So let's review this. It says 10 random samples of 20 people each are used to determine the proportion of people who support the local soccer team over the other soccer team in the league. The proportion for the samples are 0.85, and it gives you all the numbers. So what does the proportion 0.25 mean for the first sample? So you need to think about how many people in total you're talking about and what does that mean in terms of proportions. So if this is just math calculation, okay? So if I am saying that I have 85 people, I'm sorry, I have 20 people and I have 0.85, then I want to know how many people is 0.85 out of that 20. So I simply need to multiply 0.85 times 20, and that will give you 17. And let me just do it here. So 0.85 times 20, and that will be 17. So that means that 17 out of 20, okay, means that 0.85. And that was it. That's it. The mean of, so next one, the mean of the sample proportion is 0.75. The mean. Okay, so that's important. The mean is. So the mean is 0.75. And then it says, and the standard deviation is 0.08. What is the margin of error should be used for the estimate of the population proportion? So when we say margin of error, we're talking about that 95% of the data. So we just want to multiply 0.08 times 2, and that will be 0.16. And that's really everything you have to do. So, I mean, if you're not paying attention closely, if you're really just skimming through the lessons without paying any close attention, you're really missing out something very simple because you're not trying. Like, this is just multiplication times 2. Okay, when we say margin of error, automatically you should be thinking it's twice the standard deviation. There's really nothing to it. Okay, sometimes you probably overthink it, but it's not that complicated. And I think I went over that, and I said it a couple of times, that is twice the standard deviation will be the margin of error. All right, next one. It says a scientific report says that the proportion of the population that is left-handed is 0.10. So here they're talking about variability. Okay, automatically when you talk about proportions and margin of error, you need to think about the translation to mean and standard deviation. So when I have a proportion, I know that that will be, has to do with the mean. Okay, so if I say that I have a 0.8 right here with a margin of error of 0.02, then that will translate to the way they say standard deviation. So I know that if I have here my mean, and if I want to go one above the mean, that will be 0.12. And if I want to go one below, I will go 0.08. Now, let's read the questions. It says, is 0.07 a plausible estimate for the proportion of the population that is left-handed? Explain your reasoning. No, it's not, because it's less than that of the one standard, or in this case, margin of error. So, no, I cannot use that, okay? What about 0.087? Well, if you look up here, Okay, if you look up here, and by the way, this is twice as much, right? So we're talking about 95%. We're not talking, I apologize, I said one below the mean and one above. But what I meant is for you to visualize it as that, knowing that we're talking about 95%, right? So this would actually be twice below and above 95%. So 0.87, is it plausible? Yes, it is, because it's between 0.08 and 0.12, so I can use that. What about 0.128? Is that a plausible estimate? No, it's not, because it's above 0.12. So I want to be within that, not below, not above, just within that, okay? So here will be, is this no? Okay, we explain why. Is this 0.0887? No, 0.087 works? Yes, because it's within the boundary. And then 0.128, no, because it's above that. Okay, it goes above here, so I cannot use that. And that's really it. I mean, it's not, I don't want to say complicated, but it's not that you're doing a lot of huge math. It's just giving meaning to what you're saying, okay? And it's very simple calculations what you're doing. It's just a matter of interpreting what they mean.